Hi everybody, I am Adarsh. I am back again with a very new session of our crash course, and I suppose all of you have been waiting for this session, which is obviously the continuation of our previous session of oscillations. यहाँ पे oscillations के काफ़ी सारे points और काफ़ी सारे concepts use होंगे because waves में भी I'll just tell you in a while waves में कैसे oscillation का participation होता है and meanwhile जिन लोगों ने सेशन सब्सक्राइब नहीं किए हैं काइंडली सब्सक्राइब देम जिससे कि उन्हें रेगुलर अपडेट्स मिलते रहें एंड डू वॉच दिस सेशन फॉर द नेक्स्ट 2 आवर्स। जितने भी आपके डिस्ट्रैक्शंस हैं उनको साइड रखो। नेक्स्ट 2 आवर्स आई वांट यू ऑल टू डेडिकेट टू दिस लेक्चर जिसमें आप बहुत सारे कॉन्सेप्ट्स सीखोगे अबाउट वेव्स। जो लोग वेव्स पढ़ चुके हैं उनका एक बहुत अच्छा रिवीजन भी हो जाएगा। यू विल गेट टू नो कितने सारी चीज़ें और ज़्यादा इन्वॉल्व होती हैं और कितनी सारी इंपॉर्टेंट चीज़ें हैं। ऑल इन ऑल एक समरी मिल जाएगी आप लोगों को चैप्टर की इन अ वेरी गुड एंड अ क्रिस्प मैनर। साथ ही साथ कुछ अच्छे स्टैंडर्ड क्वेश्चंस भी मिलेंगे एंड मीनवाइल आई विल बी टेलिंग यू आप ऐप पे जाके भी और कैसे क्वेश्चंस प्रैक्टिस कर सकते हो। अपार्ट फ्रॉम दैट यू ऑल नो टेस्ट्स लाइव हो चुके हैं, सो व्हाट आर यू वेटिंग फॉर। आपको ऐप डाउनलोड करनी है, कोड आपके पास है, स्क्रीन पे दिख जाएगा अभी थोड़ी देर में। यूज दिस कोड, ऐप पे जाओ, कोड आईडी टेस्ट आईडी वहां एंटर करो और वहां से आप अपने टेस्ट आराम से देख सकते हो। ठीक है, यू कैन गिव द टेस्ट, एनालाइज करो खुद के स्कोर को। दिस इज अ वेरी गुड एंड अ ग्रेट अपॉर्चुनिटी। रक्तिम हाय, हाउ आर यू? एंड हाय सिद्धार्थ, हाउ आर यू? सो यार आई हैव बीन नोटिसिंग वन थिंग। आप लोग मतलब पीपल हैव बीन व्यूइंग दीज लेक्चर्स बट वो लाइव नहीं देखते, वो बाद में देखते हैं सेशंस को। देखो, लाइव देखने का एक और बेनिफिट है। बेनिफिट क्या है? यू कैन आस्क योर डाउट्स इंस्टेंटली एंड आई विल बी रिजॉल्विंग देम। और फिजिक्स एक ऐसा सब्जेक्ट है जहाँ पे डाउट्स ना आए तो फिजिक्स क्या पढ़ी हमने। फिजिक्स, whenever we study physics, doubts are just like मतलब they will come, they will arise, there's no stop to that. सो डाउट्स, एंड वो अगर डाउट्स क्लियर ना हो तो वो डाउट्स बॉटल नेक्स बन जाते हैं एंड वो बॉटल नेक्स बहुत प्रॉब्लम क्रिएट करती हैं आपकी प्रिपरेशन। हमेशा एक वो एलिमेंट आपको फियर क्रिएट करता रहेगा कि ये ऐसा क्यों नहीं हो रहा है, यहाँ पे ये प्रॉब्लम क्यों है, एंड सो मैनी, कितने सारे क्वेश्चन अराइज होते हैं। एंड यू पर्सनली नो दैट फिजिक्स पढ़ते हुए, इवन मैथ्स पढ़ते हुए, इवन केमिस्ट्री पढ़ते हुए, किसी भी सब्जेक्ट को पढ़ो पीसीएम में, डाउट्स आर मस्ट। मतलब डाउट्स तो आते ही हैं। अ पर्सन हु हैज़ नो डाउट्स means that he hasn't studied or understood the concept very clearly. Doubts is your actually how you reciprocate to any problem given to you or any concept which is explained to you. So these things are very eminent and I would just highly suggest you people, आप try करो कि sessions को आप live देख पाओ जिससे आपके doubts, problems जो भी हो यहाँ के यहाँ ही resolve हो and वो बाद में आपके लिए एक problem ना create करें। ठीक है, इसी के साथ हम सेशन स्टार्ट करते हैं। माय नेम इज आदर्श राय एंड आई एम ग्रेजुएट फ्रॉम एनआईटी भोपाल। आई माई सेल्फ हैव क्लियर्ड दिस एग्जाम way back in 2011. Okay, and that time JEE Main was actually IEEE and this JEE Advanced was IIT JEE, and that time IIT JEE used to happen earlier and IEEE used to happen after that. Okay, but today what happens is JEE Main पहले होता है and JEE Advanced बाद में होता है, which is a good thing, which is actually a good thing, जिससे आपको एक क्लियर पिक्चर भी पता चल जाती है कि if I have a good score in JEE Main then what should I do। मतलब मुझे IIT JEE के लिए भी प्रिपेयर करना चाहिए, एडवांस में फोकस करना चाहिए, नहीं करना चाहिए, मुझे और कॉलेजेस के लिए प्रिपेयर करना चाहिए, मुझे ड्रॉप लेना चाहिए। सो ये सारी चीज़ें बहुत ईजिली, बहुत जल्दी पता चल जाती हैं आप लोगों को। एंड द बेस्ट पार्ट, अब एनटीए ने आपके एक सेशन के बजाय 4 सेशंस देने स्टार्ट कर दिए हैं। So that's also a very good and a unique thing in itself because expecting that a student will perform, so बहुत problems होती हैं स्टूडेंट के साथ। It's not that कि एक दिन वो perform नहीं कर पाया, so it must only be that he hasn't studied throughout the 2 years or 3 years. There can be so many reasons. You are actually that student age, उस age में बहुत problems होती हैं and they are not definite as well. So a less performing student doesn't mean he hasn't tried his best. It's just that the day wasn't his, and that's the reason आपके पास 4 sessions है, 4 attempts हैं। So use करो, the best one of them will be actually taken into account, and जिस तरीके से आप अच्छा कॉलेज एम कर सकते हो। बहुत ही जल्द आपकी डेट्स रिलीज हो जाएंगी। अभी आपको एक बफर टाइम मिल रखा है एंड इस बफर टाइम को आपको बहुत फ्रूटफुली यूज़ करना है, एंड दैट्स द रीज़न आई एम टेलिंग यू। आप सेशंस बहुत डेडिकेटेडली और ऑनेस्टली देखो एंड साथ ही साथ टेस्ट्स प्रैक्टिस करो। टेस्ट प्रैक्टिस करने के साथ साथ क्वेश्चंस भी प्रैक्टिस करो जो ऐप पे हैं, एंड उसके बाद बहुत ही जल्द आपकी टेस्ट सीरीज लाइव हो जाएंगी, एंड टेस्ट सीरीज से आपको एक क्लियर पिक्चर पता चल जाएगी कि क्या हम वो एग्ज़ाम में केपेबल हैं या नहीं, ठीक है। सो लेट्स मूव फॉरवर्ड, एंड दिस इज एक्चुअली द ऐप विच आई एम टॉकिंग अबाउट, एक्स्ट्रामार्क्स द लर्निंग ऐप। इसकी लिंक आपको डिस्क्रिप्शन में मिल जाएगी इफ़ you don't have to hand for it, and ये दोनों ही platforms पे available भी है। There are two very striking features of this app. You can practice so many questions of any topic, you can apply some filters and try as many questions as you can. Apart from that, you can also give tests. Tests are very beneficial. टेस्ट बहुत इंपॉर्टेंट होते हैं, बिना टेस्ट के प्रॉब्लम है एनी एग्ज़ाम, ओके। सो हेलो देवेंद्र, हाउ आर यू? एंड ठीक है, सो हम स्टार्ट करते हैं अपने टॉपिक को। वेव्स बहुत ही मज़ेदार टॉपिक है, एंड ये भी बहुत वन ऑफ माई फेवरेट टॉपिक्स दिस इज। अपार्ट फ्रॉम ऑसिलेशन, वेव्स इज ऑल्सो वन ऑफ माई फेवरेट टॉपिक बिकॉज इट इज़ ऑल्सो वेरी रिलेटेबल। एक्चुअली माई पर्सनल ओपिनियन, आई विल टेल यू, entire 11th is so beautiful na, because you can just relate it with the real world. I can explain you this concept of waves, relating it with so many live examples which you see around us, ठीक है। And that's the best part, मतलब studying a thing which we can actually see, and that's really great in itself. And when I talk about 12th, so electromagnetism, optics, we don't have the capability to view light, right? Light की rays को we never ever feel कि light rays move हो रही हैं. We just get a feeling कि okay, this room is enlightened, so light है obviously, but we cannot mark those rays, and even charges are so small we cannot actually feel them. But obviously because of electromagnetism only, all the push, pull and all these forces are created. So these things are not clearly visible, but they do exist, and the best part about 11th physics is, and the topics of 11th physics are also of classical mechanics, those of Newton's time. So they are all very relatable, मतलब you can actually view them, and that's really great in itself. ऐसी physics समझना जो कि relatable हो, that's very great. And physics समझना भी हमें relate करके ही चाहिए, because if suppose we learnt ABCD and thereafter we tried creating words out of it. So now we know the usage of ABCD, right? It was just the start of a language. हम एक language English सीख रहे थे, and for that we had to learn those basic letters. So it's something like that. Physics के concept समझो and then apply it. इस चीज़ को समझने के लिए, for any happening around us, earth moving around sun, so just to understand that we need to understand the concepts of gravitation, and they are very important. And if we have understood the concepts of gravitation, thereby using those concepts and understanding why earth is continuously revolving around sun and not at all moving the orbit, not going anywhere else, then we can very well learn and imagine that how centripetal force comes into action and how gravitation is an eminent part. So these things are very good in itself, and I would definitely appreciate if you can also see the physics like I see, because that will actually be very fruitful to you, and you will seriously love this subject. So let's start the topic now. Okay, so we'll be talking about these many things during the lecture, but let's start the topic. And the first topic is, what is waves? What is waves for the first case? We are starting this chapter of waves, but what is waves? So waves is a disturbance. It is a disturbance which is created, and that disturbance travels, and that disturbance is obviously wave. Okay, so a wave is a disturbance which propagates energy and momentum from one point to another, and the medium, the way can be many, but for a layman term, wave is what? It's a disturbance. Suppose you create a disturbance on a rope. So you just created a disturbance, and that disturbance is flowing in forward direction, and this is what wave is. So you have created a wave. Okay, and waves can normally be classified into two things. One is the mechanical wave, and what is mechanical wave? The waves which require medium to travel. So can you think of any wave which requires medium to travel? Yes, sound waves. Sound waves, and sound waves do require medium, right? So I am speaking and my voice is being recorded, and you are able to hear it through your speakers. That means sound can travel, and it can only travel when we have atmosphere around us, when air is around us. So suppose you just take those speakers and go to moon. Will you think that you can ever hear that sound? No, because that sound will not propagate. So sound requires medium, and sound is a very classic example of what mechanical waves are, or just a tension or a disturbance created on a rope. That is also a mechanical wave. So these are the examples of mechanical waves on string and spring, waves on water surface, sound waves, seismic waves. Seismic waves also require medium. So they do travel. There are three kind of waves whenever a seismic activity is occurring, and this p-type and secondary wave and primary wave, and the havoc is created by one of the waves, but that's something else, that's a portion of geography. What I want is that these seismic waves are also traveling through the entire planet. So an earthquake occurring in Indonesia will have its tremors, or the waves will travel throughout the entire planet. So a person sitting in USA will also feel those waves, but in a very limited amount. Okay. Now let's talk about the other variant, that is non-mechanical waves. So what are non-mechanical waves? So non-mechanical waves are those waves which do not require a medium, like electromagnetic waves. And what are electromagnetic waves? So electromagnetic waves are starting from lambda equal to 0 till lambda equal to infinity, and the major ones are light rays, heat waves, and then infrared waves, then radio waves, X-rays, gamma rays. All these are electromagnetic rays. And what is the striking feature about electromagnetic waves? That their electric field and magnetic field are continuously oscillating. They are a type of longitudinal wave in itself, wherein electric field vector and magnetic field vector are continuously oscillating in the same phase, and that too in a perpendicular fashion to each other, and perpendicular fashion even to the propagation of that wave even. And we'll be discussing about that when we'll be discussing about electromagnetic waves chapter. So what are they? The features about an electromagnetic wave will be discussed in much details when we'll be talking about electromagnetic waves. But for the time being, you should just understand that there are some waves which do not require a medium to travel, to propagate, and those waves are obviously known as non-mechanical waves. And the best example is electromagnetic waves, and even you can just filter them out with in light rays, the visible spectrum, the visible light rays, they are also electromagnetic spectrum, electromagnetic waves, and then X-rays are also there. So there are so many. Okay, now let's talk about the other variant. So this was the division of waves on the basis of whether they require a medium or not. Okay, so now the differentiation of wave is being done about the oscillation of medium particles with respect to the propagation of waves direction. Okay, and based on that criteria, so depending upon the criteria, differentiation can be done, right? Even forces have been based on nature. There are 4 forces. Based on the work done, there are 2 types, conservative, non-conservative. So something like that only. Waves are distributed among mechanical, non-mechanical based on whether they require a medium to travel or not, but on the basis of the oscillations of medium particle with respect to the propagation of waves direction, they have been again segmented into 2 segments, and the one in front of you is transverse wave. So what happens in a transverse wave is that the medium particles, they do oscillate. Whenever I am talking about oscillations, that means there is a mean position and there will be 2 extreme positions. So they do oscillate, and the direction of their oscillation is perpendicular to the wave's propagation direction. So suppose the wave is moving in forward direction. So the direction of oscillation of the particles will be perpendicular to the direction in which the wave is moving, and this is what transverse wave is. Okay, any example? So transverse waves mostly occurs in springs or on the surface. Okay, because transverse waves requires those tension created, and tension obviously cannot be created in solids. Okay, no, sorry, tension cannot be created in liquids, liquid inside the liquid or inside the gases. So gases and liquids don't really create a transverse wave in them. Transverse waves are actually getting created in solids only, and the best example to understand a transverse wave is the disturbance created on a string. So suppose there is a string and you just created a disturbance, something like this. So this disturbance will continuously move in forward direction, and what is the direction of motion of the particles? So if you just point any particle, so since this entire disturbance is moving in forward direction, so this particle initially will go up to a maximum point, then will come down, then will again go up. So it will just keep on oscillating about its mean position, that is this position, and this oscillation will obviously of a simple harmonic motion. So that's the reason SHM is taught just before waves is done, and the reason is because the medium particles oscillate simple harmonically, and we'll be just understanding how they are doing that, and maths will tell us. So we don't have to get into that. Even maths is going to tell us that how the motion of medium particles are performing a simple harmonic motion. Okay, so I think you just got the idea behind transverse waves, and the other variant is longitudinal waves, wherein the medium particles are oscillating in the direction of motion of the wave. Okay, so suppose the wave is propagating in forward direction, then the medium particles are in motion. They again are performing simple harmonic motion, but the medium particles motion is along the direction in which the wave is propagating. And the best example is sound waves. So sound waves, if you make them travel in air or solids or liquids, wherever, they travel through rarefaction and compression, and this is the complete model of a rarefaction and compression. So what happens is, suppose there is no sound wave traveling. So if no sound wave is traveling, then the arrangement of molecules is very uniform. Okay, and let's take the case of a solid, because in gases obviously molecules are continuously moving. So let's take the case of a solid. So molecules are uniform. So as the disturbance is created, if you have just seen a speaker, if there is a speaker in front of you, you can just observe that there is a diaphragm which continuously vibrates at a very high frequency, thereby creating a sound. Okay, so based on the diaphragm which creates a disturbance, some particles go over there, and these particles come over here, and these particles go over there near to the other ones, the adjacent ones. And due to that, what happens is, in this region the particles come closer, in this region the particles come closer, but in this region the particles got away. So there is a region of lesser density, lesser pressure. Pressure variations arises, and those pressure variations have been termed by the terms of compression and rarefactions. So compression is basically the region where molecules have come closer, and obviously the pressure has increased, the density is also increased. And rarefactions are the region where molecules have just separated apart, and thereby the density has been reduced, and obviously the pressure also has been reduced. So based on pressure variations, the transfer of energy is occurring, or all in all, that wave is propagating, and this is what a longitudinal wave is. Okay, so I suppose you all must be knowing about longitudinal waves. This is something, not a new thing which I am talking about. It's just an insight which I want you all to have, that what is the basic differentiation between a longitudinal wave and a transverse wave. And talking about the equations, so the equations will be quite uniform in itself. Obviously the equations of longitudinal wave should be in terms of pressure difference, but we will be using y is equal to a sin kx plus omega t plus phi only to represent them, where y obviously will be depicting the pressure variations. Okay, so maximum pressure variations will be obviously represented by a. So same kind of equations will be used, but the ideation, the normal thing, which is the exact thing which is happening, you should have a clear insight about that. Okay, so now let's move ahead and talk about some very important terms related with waves. Okay, hi Shinchan, how are you? Hi Avi. Thank you, Avi. I'm also a big fan of yours. Do watch these sessions, they will be very beneficial for you. And let's talk about the first term of a wave, that is wavelength. So what is a wavelength? So wavelength is actually the distance between any two points which are in the same phase. And this term which I am telling you, that phase thing, so obviously that is quite evident in itself which 2 points I am talking about. So let's say, suppose these are the 2 points which are at the same position. Obviously they have the same value of y. But they are not in the same phase, and the reason is, this particle, suppose a disturbance is traveling in forward direction, so the pattern just before this point will be a lower curve like this, and it will come over here. So this particle will obviously move downward, and just before it this upper curve is there, and when it will move upward, when it will move in forward direction, this particle will move upward. So obviously they are not in the same phase, because just after the moment when I just release them, one of them is going down, one of them is going up. So that is obviously not lambda, and lambda has to be this distance. So whenever this pattern is moving up, 2 points at the same position, having the same velocity, direction as well as magnitude, are said to be in the same phase, and obviously this is the value of lambda. So you should have a clear picture what lambda is, and I suppose you now have understood what the lambda is. And in this manner only, this distance, so suppose one compression and one rarefaction is obviously the distance of 1 lambda whenever I talk about a longitudinal wave, and this is the case in a transverse wave. Okay, And even don't ever think like that a transverse wave cannot be, sorry, a longitudinal wave cannot be plotted like this, like a sinusoidal pattern. They can, obviously. This will be depicted by what? This will be depicted by the maximum pressure change, okay, the value of delta P naught. Okay, so this expression is just for your sake, so that you should also understand, but it can be obviously represented like this also. Okay, now so wavelength, I suppose you all must have understood. Now the next term is frequency, and obviously since oscillations are occurring, we had to know about frequency, and frequency is what? It's 1 upon time period, and time period is what? It's 2 pi upon omega. And what is omega? It's the angular frequency. And what is angular frequency? We'll have a general expression of a wave to understand that, and so is time period. And the next thing is relation between frequency and time period, and very well, even a kid knows now that frequency is inversely related with time period. More is your time period, lesser will be your frequency. More is your frequency, lesser will be your time period. That's a simple fact. And relation between velocity, frequency and wavelength, this is very important. So how you should remember this is that obviously velocity is distance upon time, right? So what happens is, in one time period, the medium particle oscillates completely. It undergoes a one oscillation, and during one oscillation, the wave propagates by a distance of lambda, that is one wavelength. So what happens is, if I make this time as capital T, the distance covered by the wave, because obviously we are talking about the velocity of a wave, not the velocity of a medium particle. This is obviously the velocity of a wave. So velocity of a wave will obviously be equal to lambda upon T, and this 1 upon T can be instead written as lambda into f, where f is obviously what? It is the frequency. So V is equal to f lambda. You should just remember this expression, V is equal to f lambda. And obviously you should, because in organ pipes we'll be very readily using this expression to calculate the velocity, frequency and so many things. Okay, so you should remember this. And now let's talk about the general equation of a wave. So a general equation of a wave is actually represented by y is equal to a sine omega t minus kx, plus phi can also arise if there is an initial phase, but just for simplicity, because we need to finally get to the relations and expressions of velocity and acceleration, we have written a simpler expression. And obviously if phi rises, then obviously in velocity and acceleration also that phi term will come into action. Also, instead of this sine term, we can instead have a cos term as well. So when I teach students about waves, so what I actually tell them to do is try relating it with simple harmonic motion. So what happened in a simple harmonic motion was that x was plotted in terms of t. Okay, x was plotted in terms of t. The general expression was x is equal to a sine omega t plus phi minus phi, whatever it is. So with the variations in t, x had some variations. Okay, so x was all obviously a function of time. And if you can notice over here is that y has been represented in terms of time, that's very evident, but in terms of x as well. So y simultaneously is depending upon two parameters. So this equation is actually relating the unknown variable which you obviously need to find, and the entire discussion is all about that, what is the position of the medium particle. So y over here is representing what? It is representing the position of the particle. Okay, the position of the particle, at what position it is from that mean line, from that mean position. Okay, and this y will obviously be a sinusoidal function of x and t. So do one thing, and I want you all to just imagine one thing. So let's imagine a photograph. So what happens in a photograph is, the very good definition of a photograph is that you captured a moment, and instead in terms of physics or maths, I say that you actually made the time constant. So suppose at t is equal to 400 hours, you just took a snip of some friends of yours or yourself only. Then what you did was you actually made the time constant. And if you made the time constant, so suppose there's a wave traveling, there's a traveling wave, you have created a disturbance and there's a traveling wave in forward direction, and you just take a snip of that, you just take the image, and what you do is you make the time constant. So you have the ability to make time constant. That's very good of you. And now what you can see is you can clearly analyze. So suppose if time is constant, then we can very well relate y with x, right? So for different values of x, you can see there are different values of y. And this is only the approach we should use, because having three variables intermingled in a single equation will always create trouble for you. If you notice the changes in y with respect to x, then obviously you cannot be very clear with your observations, because time can also change, right? So first you will have to take time as constant, and that's the best approach. Take a image, take a snip of anything or a wave traveling, and depending on the variations of x, suppose I am talking about x at this distance, then y is this. I am talking about x at this distance, then y is this. If I am talking about x at this distance, then y is equal to 0. So depending upon x, I can very well check the variations in the value of y, and for checking the variations of y with respect to t, what you need to do, you fix a position. So suppose there is a traveling wave, and there is a traveling wave, and what you do is you just fix a position of this point. Okay, so your x is fixed now. You just fix this position and you just observe this point. What do? You just observe this point, and what you will see is this point is continuously moving in forward, in upward and downward direction. Okay, so this object is obviously performing simple harmonic motion. So now the variation of y can be determined with respect to t when x is constant, and this is the only approach to understand what this equation is all about and to actually get a feeling of waves. So I suppose I have just conveyed you the better approach to understand what waves are, and waves are obviously a function, thereby relating the position of the particle with respect to the x and the time. Okay, so a single equation relating three variables, and how we need to understand, I just told you. Now what we can do is just differentiating this y with respect to time will give you the value of the velocity of particle at any time, at any instant of time, and at any position x. So just differentiate it, what you will get is you will get the relation as a omega cos of omega t minus kx, and that's very clear. And differentiate it again. So what you will be instead getting is the acceleration of the particle, and that will arise instead to be minus of a omega square sine of omega t minus kx. And if you are very clearly looking towards these expressions, then you can see that this a sine of omega t minus x is obviously y. So AP is turning out to be minus of omega square y, and if that is the case, this is arising as a of particle is equal to minus of omega square y of particle, that is position of particle. And if you are very clear with the simple harmonic motion concepts, or if you have attended the previous lecture also, those who haven't attended, I personally recommend them to do watch it. It was just held yesterday, and you can find the link to it, Oscillations and SHM, and thereby you will now understand that yes, the particles are performing simple harmonic motion, since the acceleration is directly proportional to the displacement from the mean position, and that too with a negative sign. So omega square will obviously be what? It will be value of the time period of the medium particles. Okay, so this was the case which I wanted you all to understand. Now let's talk about some more data which we have derived using these equations. So first thing will be, now we differentiated that expression of y, the position of y with respect to time, and thereby found out the values of velocity and acceleration. Now let's do one more thing. Now let's differentiate the y with respect to x, because obviously y is changing, and the change is depending upon two variables, x and y, x and t both. So you can differentiate y with respect to x, and what you will be getting is the slope of an xy curve, or the slope when the position of the medium particle is plotted with the x, that is from the point which you have started where the disturbance is being created, and the position of whichever point you want to measure. Okay, so you will get the slope of that curve, okay, x and y should be very clear in front of you, that x is obviously what? X is the point from which you are starting, so this is the value of x, and y is obviously the position of the medium particles. So we will get the value of the slope, and we can also differentiate it, and the value of this also I can very well write. So the value of this will be equal to ak sine, cos ak cos of omega t minus kx. Okay, ak cos of omega t minus kx, this gives you the value of del y by del x, and this del sign is obviously a parameter. It's a differential operator, partial differential operator, thereby saying that differentiate y with respect to x only and consider time to be constant. So this is what that partial differentiation means. And if I again differentiate it, and sir, why are you differentiating it again? Because I am just creating a condition for a traveling wave, and if you can see, this is the condition of a traveling wave, wherein this is d square y upon dx square, right? This is d square y upon dx square, and you also have the value of d square y upon dt square. So can you just divide them both? Can you just divide them both? You need to do d square y upon dx square divided by d square y upon dt square, and what you will get is that a sine omega t minus kx will be equivalent to 0, but the other thing remaining will be, over here it will be omega square and over here it will be k square, and omega square upon k square is what velocity of a wave is. Okay, so I am again repeating myself. This is actually the condition of a traveling wave. And why this is important? Because after some time I will be discussing about a standing wave, even how it is created. So you should very well know what is the condition of a traveling wave. So all the traveling waves, differentiate them with respect to time, the second order differentiation, and if they are getting related in such a fashion, then obviously your wave, the equation which you have got, is actually representing a traveling wave. Okay, and V is obviously written over here to be omega square upon k square. So this V is what? This is obviously velocity of wave, and velocity of wave can be written as omega by k. How, sir? We just gave us a formula that V is equal to F times lambda. The result is turning out to be same only. So omega, how omega can be represented? Omega is 2 pi upon, or 2 pi f can be written. Or what about lambda? No, what about k? So what is k first of all? K is k is the angular wave number, and it is equivalent to 2 pi upon lambda. Always remember what is the value of k. K is 2 pi upon lambda. What it is? It is 2 pi upon lambda. So just replace k by 2 pi upon lambda. 2 pi will get cancelled, and what you will be remaining up with is f lambda, and that is what? That is in turn velocity of a wave. Okay, so velocity of a wave can be very well determined using this result, and you should remember both the formulas. Okay, this omega by k and f lambda as well. And even I just want to give you a very crisp and clear formula. So just look over here in this case. So what you can see is, this is the general expression of a wave, right? This is the general expression of a wave, and what I want you all to memorize about the velocity of a wave is that the velocity of a wave, so suppose you are given a general equation of any wave, किसी भी wave की आपको general equation दी है, and you need to find the velocity of wave from that. So can you, sir, omega by k कर देंगे? No, don't do by that approach. आपको क्या करना है? आपको करना है minus of coefficient of x, coefficient of t divided by coefficient of x. क्लियर है? आई सपोज क्लियर है. सो यहाँ पे कोएफिशिएंट ऑफ t क्या है? कोएफिशिएंट ऑफ t है सर ओमेगा. सो हियर विल कम ओमेगा. एंड व्हाट अबाउट कोएफिशिएंट ऑफ x? सो कोएफिशिएंट ऑफ x साइन के साथ लेना है. सो साइन के साथ व्हाट विल बी द वैल्यू ऑफ कोएफिशिएंट ऑफ x? इट विल बी इक्वल टू माइनस k. सो यहाँ पे आ जाएगा माइनस k. एंड व्हाट दिस रिलेशन विल ऑल्सो टेल यू दैट नेगेटिव नेगेटिव विल गेट कैंसिल. मैग्नीट्यूड तो हमें पता चल गया, दैट विल बी इक्वल टू ओमेगा बाय k. बट साथ ही साथ यहाँ पे आप, इफ यू नोटिस, there is a positive sign. If there is no negative sign, then obviously the sign is of positive. So positive sign means that this wave is moving along positive direction of x-axis. Okay, I'm again repeating myself. To find the velocity of wave from any general expression of a wave is, the formula is minus of coefficient of t upon coefficient of x, and on doing that you'll get the result. And if the answer is turning out to be negative, then obviously you should say that the wave is traveling in negative x direction, and if the answer is coming out to be a positive function, a positive value, then the wave is traveling in positive direction of x-axis, and this is very important. Okay, this is very important. Now, because we will be solving this case over here. Okay, so what this says is a transverse displacement, the transverse displacement y of a wave on a string is given by. So this is a wave. You don't have to question yourself that whether it's a wave or not, because there is no sinusoidal function. It is a wave. Now what we need to do, this represents a wave of a wave moving in negative x direction with speed under root of b by a. Say suppose if we are getting a value of b, if we are getting a value of v, that is velocity, then it cannot be a standing wave, right? Because standing waves, I'll be just telling you, they don't move, they don't travel. So obviously standing waves option A and B obviously gets deducted, and elimination of options are very important, and I have tried my best to make you learn that. In all the chapters and in the coming chapters as well, I'll be telling you how elimination of options can actually reduce your risk of getting wrong answers. So first you should be very clear with what is the wrong path, and then you should be left out with some paths among which the chances of catching a wrong path gets reduced. So now we have two options. Okay, wave moving in positive direction, wave moving in negative x direction with speed. So they have mentioned the speed, and this is the change, and obviously minus an x is also the change. So can we calculate the value of speed from this result? Yes, we'll try our best. So what is the expression given to us? So expression is given to us as e to the power minus of ax square plus bt square plus 2 times under root of ab into xt. Okay, very well, very well. Now this is a very complex relation, right? But I can see one thing. Can't you just reduce this equation in the form of a plus b whole square? I can view that. Can you? Can you? And I want you all to know this as well. Arpit, how are you? I'm good. Good evening. So where can I get last 10 years JEE Main PYQs PDF for free? Google, Krishna, Google is the best source. You will be directed to so many websites, and you can obviously find them, right? And hello sir, hello, how are you yaar? Hi to everybody and very good evening to everybody. Okay, so now let's solve this question. Can you just see this expression? इस expression को आप देखो और क्या इसको a plus b square के form में convert कर सकते हो? देखो, I can find the value of, क्योंकि मैं आपका सर हूँ या आपके जो भी सर हैं उन्होंने आपको क्या पढ़ाया कि वेलोसिटी ऑफ वेव निकालने के लिए माइनस ऑफ कोएफिशिएंट ऑफ टी अपॉन कोएफिशिएंट ऑफ एक्स बताना है. अब कोएफिशिएंट ऑफ टी तो यहाँ दिख नहीं रहा, कोएफिशिएंट ऑफ टी स्क्वायर दिख रहा है, लेकिन यहाँ पे भी कोएफिशिएंट ऑफ टी, तो मैं कैसे करूँ? व्हाट्स द अप्रोच? कैसे किया जा सकता है? सो द अप्रोच इज, इसको रिड्यूस करते हैं. एंड इसको रिड्यूस कैसे करते हैं? आई कैन वेरी वेल लुक एट इट. तो देखो, इसको लिखूंगा माइनस रूट ए इंटू एक्स होल स्क्वायर प्लस रूट बी इंटू टी होल स्क्वायर, और इसको लिखूंगा मैं 2 टाइम्स रूट ए एक्स इंटू रूट बी टी. ठीक है, एंड ये पूरा आ जाएगा एज अ फंक्शन. सो अब आप देख पा रहे हो ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab, and this is what? This will be obviously e to the power minus of a plus b whole square. That means root ax plus root b t whole square. Okay, and this is your result. So आपने इसको break down कर दिया. You have now reduced this function in a very simpler form, and इसके बाद what you now need to do is, you now need to just remember that formula. That is, velocity of wave is what? Velocity of wave can be found out and the result is minus of coefficient of t upon coefficient of x. And what is the coefficient of t over here? It's root b. So this will be root b divided by, what is the coefficient of a over here? So the coefficient of a is root a, and what is the answer turning out to be? So it will turn out to be under root of b by a. Clear? Yes sir, very clear. तो क्या समझ में आ रहा है यहाँ से? Obviously ये रहा आपकी speed, and क्योंकि यहाँ पे negative दिया हुआ है, that means wave is traveling along negative direction of x-axis. ठीक है? So I suppose you just understood, and don't get into that whether there is a wave or not. सर इसको proof करके दिखाओ. Proof कर सकते हो आप, d square y by dx square करो is equal to वो जो equation दिखाई थी उसके through proof कर लो. But why to get into that trouble? Nobody is checking your differentiation and calculus skills over here. Okay, what they just want from you is you should understand the physics. Nobody wants mathematics out of you. Okay, and they obviously want in some way or the other, कुछ जगह पे obviously, because maths is the language of physics. Without understanding maths, you obviously cannot get to a final result or a very good result which can be conveyed to somebody. But excessive expressions or excessive utilization of maths is also trouble for you, because फिजिक्स वहाँ पे कॉम्प्रोमाइज ना हो जाए. ठीक है, सो फिजिक्स हमें क्लियरली समझ में आनी चाहिए, एंड फिजिक्स यही थी कि हमने कैसे इस वेव का वो फॉर्मूला यूज करके माइनस ऑफ कोएफिशिएंट ऑफ टी अपन कोएफिशिएंट ऑफ एक्स से वेलोसिटी निकाल ली, एंड दिस इज द राइट आंसर. आई सपोज यू जस्ट गॉट दिस पॉइंट. हाय नरेश, हाउ आर यू? एंड नाउ लेट्स मूव अहेड एंड टॉक अबाउट वेलोसिटी ऑफ साउंड and longitudinal waves in solids. But before that, I also want to tell you what is the velocity of transverse wave. So transverse wave क्योंकि बस स्ट्रिंग्स और रोप पे ही हो पाती हैं, वन डायमेंशनल बॉडीज में हो पाती हैं. सो ट्रांसवर्स वेव का जो वेलोसिटी होता है दैट इज इक्वलेंट टू अंडर रूट ऑफ t by mu, and I want you all to remember this, where t is what? T is the tension. Suppose there's a wave getting created in this wire, so the wire should always be stretched. A slack wire can never ever create a wave in it, so there should be some tension. So that tension divided by its linear mass density, and that is what mu is. Okay, so total mass divided by total length will give you the value of linear mass density. So t by mu to the under root will give you the value of velocity of a transverse wave created on a string, and I want you all to remember this expression. Okay, so we knew that, and now let's proceed further with the velocities of longitudinal waves when they are created in solids. Okay, so whenever I talk about a solid, so in solid the expression of velocity is under root of y by rho, where y is what? It's the Young's modulus of elasticity. Okay, and obviously those stress strain elasticity constants should come into picture because there's a pressure difference which is getting transmitted, right? So there obviously will be some amount of strain, and that strain is transmitting from one point to another, and because of that only that energy is getting transmitted, or a wave is getting transmitted from one place to another. Okay, so that element had to come, and over here there are key what is the expression of velocity in a rod? So suppose a rod is there and there is sound getting traveled from one point to another end of the rod, then the traveling rate or the velocity will be equivalent to under root of y by rho. But this is not the very famous or the more popular formula which is asked. The more popular one is when I get into fluids and even for solids, bulky, very big solids. So this is the expression only for rods, one dimensional, or ropes. Okay. Now if I talk about three-dimensional objects, and obviously we are surrounded by three-dimensional objects, so the transmission of waves, of longitudinal waves, will have a velocity equivalent to under root of b by rho, and b is what? It is the value of bulk modulus of elasticity, because when a wave is propagating, entire volumes are getting compressed and expanded. Okay, so there is an element of delta v by v, and hence bulk stress comes into action and bulk modulus of elasticity replaces y. So this is the expression for velocity of a wave in any solid or any liquid or any gases. Okay, and bulk modulus of elasticity can be expressed for all these objects, for all the matter, right? And by that only, what I want you all to, if you remember that lecture of stress strain of mechanical properties of solids, I clearly told you that the bulk modulus of any substance depends upon the value of k. So who has the maximum value of k? So first of all, b will be an inverse function of k, right? B will be an inverse function of k, and k is what? It is compressibility. So who has maximum compressibility? Who will have the maximum value of compressibility? The maximum value of compressibility will be with gas, so they will have the least value of bulk modulus of elasticity, and the compressibility will be very least for solids. Obviously, just imagine 1 meter cube of solid, liquid and gases. So those 1 meter cube of gases can obviously be compressed and they can be liquefied even, and that is the thing happening with LPG cylinders. Those if those LPG cylinders are just about to entire fuel inside an LPG cylinder is made to release, it can fill the entire room of ours. So the gases are compressed, so it is very easier to compress a gas, and if it is very easier to compress a gas, that means its compressibility is very high. We can compress it very much as compared to a solid which cannot be compressed. So a gas will have the maximum value of compressibility and the least value of bulk modulus. On the other hand, a solid will have the least value of compressibility and the max value of bulk modulus. So what can you say about a sound traveling in a solid, liquid and gas? So a sound traveling in a solid will have the maximum velocity as compared to the sound traveling in air. So sound traveling in air has a velocity near about 340 meter per second, and if I talk about solids, then it is above 1000 meter per second. Okay, and this is the fact, this is a fact, and you should very well know that what is the variation in the speed of sound whenever I move from a solid liquid to a gas, and obviously decreases. Okay, so this is the point, and there are two famous scientists, Newton and Laplace, which have changed this format. They were not at all very much interested with this B bulk modulus of elasticity. They wanted some real physical quantity which is used more rapidly. So they have replaced it by P, and we'll be going for that, but let's just discuss this question before proceeding further. So what this says is the equation of a wave on a string of linear mass density 0.04 kg per meter. This is obviously what? It is the linear mass density, that is lambda, is given by this. The tension in the string is. So I just clearly told you this is an equation, and tension will be equal to, velocity will be equal to under root of T by mu, right? T by mu. So what can you say about, you need to calculate the value of T. We are given with the value of mu. Can we calculate the value of V? Can we do that? Yes, we can. We know the formula velocity of a wave, and velocity of a wave is the coefficient minus of coefficient of T divided by coefficient of X. So minus of coefficient of T is 1 upon 0.04. Very well, sir. And what is the coefficient of X? It is equal to minus of 1 upon 0.50. Okay, that's also very nice. Now what I need to do, just numerator denominator sab adjust karte hain, and this 0.5 will go above, the 0.04 will come down, decimal hatayenge, so we will be remaining up with 50 by 4 meter per second, and this is our wave. So that means the wave is moving 12.5 meter per second. That's a very good speed, right? 12.5 meter per second, that means 10 seconds में 125 meter के around move कर जाएगी, near to the speed of Usain Bolt. ठीक है. So now let's talk about how to calculate T. So T can be very well be calculated. We just need to square both the sides. So V square times mu. And what is the value of mu? It can be written from that expression. Mu is also known to us. It will be 4 by 100, right? So 50 by 4 whole square into 4 by 100, right? Yes, sir, perfect. So 1 4 will get deducted by this 4, and this expression will in turn turn out to be, let me just erase this. So the expression will turn out to be 50 into 50, 150 will get cancelled by this 100, and the result will be 50 by 2, and 1 4 will get deducted by this 4, so there will be remaining 1 4. And what is 50 by 8? So 50 by 4 was obviously 12.5, and 12.5 divided by 2 now will be 6.25. And are you getting the point that most of my calculations are orally, and this is what you should also do. Maximum calculations should be orally. This will save a lot amount of time of yours. Initially you might do some silly mistakes, but eventually the final result will be like that. Most of your calculations, most of your thinking is all in your brain, and that's the best part of you, because if your brain is working, your brain will never get tired by doing calculations. It is you who just avoid such calculations, okay? And you should definitely develop the skill that most amount of calculations. So people, when they if you'll after graduation, if you are about to, some of you might be interested in doing MBA and going for that finance option, they will be loving about that finance thing. So obviously they should have that knack of that mental ability and that quantitative ability in them, that calculations are very at ease to them. They can just calculate it in their minds, entire pros and cons of any event or any probability, any problem occurring. They obviously know the pros and cons, and that is the most striking feature of an engineer. They should know. Most of the things should run in the mind. They should have a vision about that. And the best way to learn is to calculate mathematical equations, all the multiplication, divisions in your mind. Don't use a pen and paper. Obviously, I know initially you might get things wrong, but slowly and steadily you will be perfecting yourself to a very better stage. So it's my personal recommendation. You should definitely follow it. And is it the right answer? Yes, obviously it is. So we are absolutely correct, okay? And if you like this lecture, yeah, if you are loving these lectures, hit us a like button. We require them, because, and for any suggestions, modifications in the lectures, if you want, your suggestions could be anything, but we would definitely love to know about them. So in the comments, comment about them, what you want from these lectures, how you are liking it, and will you share them with your friends, and was there any takeaway element from these lectures to you, and was your ongoing preparation getting better or worse? Whatever the reviews are, we'll be highly delighted to know them. Okay, now let's move ahead and talk about the Newton's formula as I was discussing. So Newton and Laplace, they weren't very much interested or very happy with the relation of velocity of sound in a solid, liquid or gas that is given by under root of b by rho, and they wanted to change it. So they came out with a different concept, not a different concept, they just went into it further and tried explaining how sound is actually propagating. So Newton said that whenever a sound is getting propagated, okay, whenever the sound is getting propagated, so what happens is the temperature of the medium remains constant. The temperature of the medium remains constant, and the entire work done in compressing and expanding is adjusted by the external heat energy. So heat is getting absorbed, heat is getting released based on compression and rarefactions. So what he just hinted towards was that the propagation of sound is an isothermal process. Okay, it is an isothermal process, and if it is an isothermal process, then obviously we can consider gases, we are taking the gases to be ideal, so we can consider them to be PV is equal to constant, because PV is equal to nRT, number of moles are constant, R is obviously constant, and even temperature now is constant, so PV will be constant. Okay, so PV is constant, so he suggested that the propagation of sound in any medium is an isothermal process and PV will be constant in it. So if PV is constant, I can very well replace that B. So what was B? What was B? B was obviously P upon delta V by V, or you can also replace this P by the excess pressure, and there was a minus sign also, because obviously because of this excess pressure the volume decreased, and volume decreased, that means final volume was obviously lesser than the initial volume. So B is this, and I can very well calculate the value of delta P from this expression, and just look over here. So PV is equal to constant, just differentiate both the terms, so PdV plus VdP is equal to 0. Then from this expression you can very well calculate the value of minus VdP upon dV, and what will be minus VdP upon dV? Just replace these delta signs with the help of D, so you will get the value of B only. Okay, so this from this expression minus of V dP upon dV is coming out to be equivalent to P, and this P can be replaced over here in place of bulk modulus of elasticity. So the entire expression of velocity will turn out to be under root of P by rho. Okay, this will turn out to be P by rho, and P is what? P is what? P can be further replaced by nRT upon V, because temperature is constant. So this, you can keep up with this expression also, but a clear picture will be much more evident when temperature comes into this expression. So this P can further be replaced by PV is equal to nRT, so P will be equal to nRT by V. Okay, still I am not convinced, so what I will do, I will just replace this mass m by, I'll replace this small n, that is the number of moles divided by the total mass of the gas divided by its molecular mass. Okay, m upon mo. And this m upon v, mass upon volume, the mass of the gas divided by its volume is what? It is density. So this P further turns out to be equivalent to rho RT upon m naught, that is molecular mass. And I can now replace this P, I can bring this rho beneath P, मैं इस rho को P के नीचे ले आऊंगा, so P by rho will further turn out to be RT upon m naught. So P by rho की जगह मैंने क्या लिख दिया? RT upon m naught. So मेरा velocity of wave क्या आ जाएगा? Velocity of wave आ जाएगा under root of RT upon m naught. And ये expression ज़्यादा अच्छा है भी इसलिए, because what happens is we get a confusion that velocity is directly proportional to pressure, inversely proportional to density. So हम density बढ़ाएंगे, velocity of wave कम हो जाएगी, density कम करेंगे, velocity of wave बढ़ जाएगी, और प्रेशर बढ़ाएंगे तो वेलोसिटी बढ़ जाएगी, प्रेशर कम करेंगे वेलोसिटी कम हो जाएगी. बट द मेन प्रॉब्लम इज इफ यू आर इंक्रीजिंग द प्रेशर, देन ऑब्वियसली डेंसिटी इज आल्सो इंक्रीजिंग इन द सेम अमाउंट. एज यू कैन सी ओवर हियर, P is directly related with rho, right? So if you are increasing the pressure, then density also increases. If you are decreasing the pressure, the density also reduces, and the overall change in the value of V remains null. So what is the point in having a relation where you just cannot derive a thing out of it? Ki if you are changing the LHS, RHS isn't changing, because the LHS, the RHS only is the changes are getting mingled up over there only, and with the change in P, rho is also changing, and there is no effect on V. So this is a better expression, right? Velocity is equal to under root of RT upon m naught. And obviously R is constant and m naught also can be derived. We just need to know the gas. We very well know the periodic classification of elements, right? We know their molecular masses. This much I suppose all of you must be knowing what is the periodic classification of masses and how their molecular masses are. And also, so only the term with which velocity of sound is related is temperature. So velocity is directly proportional to temperature. Okay, so if we increase the temperature, velocity increases. If we decrease the temperature, velocity decreases. Very well. But Laplace was not very convinced with it. What he said was that during a propagation of sound, what happens is it is so rapid, it occurs obviously 340 meter per second in sound. The 340 meter per second velocity is in air, and if we go for liquids and solids, the velocity is further increasing. So it is very fast, right? It is not like us moving from one point to another point. It is obviously happening very fast, and in such a fast process, you can never expect that the energy change will occur between the surrounding and the medium. The sound flows just in a just flash of a second, and there is no exchange of heat occurring from the surroundings and the system. So what he derived from this result was that what you told, if you remember that equation of first law of thermodynamics, delta Q equals to delta U plus delta W. So in the previous case, delta U was 0, so delta Q and delta W adjusted themselves, and in this case what Laplace said is that delta Q will be equal to 0 and delta U and delta W will adjust themselves. So what he just pointed towards was that the propagation of sound is an adiabatic process, not an isothermal one. And why he is, suppose he just negating the facts of Newton was a very big thing back then, okay, because Newton was considered just like a god, and just challenging a god was very tough. But he realized that, and he told, and what happened was the final results of velocity of sound which we received was near to the values given by Laplace and not Newton. So that's the reason this is the correct expression, and propagation of sound is not isothermal, it is adiabatic, and hence PV to the power gamma will be constant. Okay, PV to the power gamma will be constant, and then doing the same thing over here as well, you will finally get the expression that velocity of sound waves is turning out to be gamma times P by rho, and P by rho can further be replaced by RT upon m naught. So this will further turn out to be V is equal to under root of gamma RT upon m naught, that is molecular weight. Okay, and this is the final expression which you should keep in mind. Okay, velocity is directly proportional to under root of temperature. Okay, and there are further other elements also which create a change on the velocity of sound's value. Whatever is the velocity of sound, whatever value it is, there are some other elements, some other factors also which create a change, and one of the changes is obviously temperature. So on increasing temperature, velocity increases. On changing pressure and rho, I'm sure you all must be knowing now, pressure and rho, they just are so interrelated with each other. If you change one, the other already changes itself, so there's no point discussing about them. You just need to focus your attention towards T only, and apart from that, humidity also have an effect on sound. So what humidity does is, if there is more humid air, so what happens in northern India is, if I'm specifically talking about the regions of NCR, then Punjab, then Haryana. So what happens over here after when the summers have are just going away, and rainy season has just arrived, so it don't rains too much, but the humidity in the air, it increases, and air has a very good humidity, the percentage reaches around 80-85%. So the air is very humid. So what happens is, where that humidity comes from? That humidity comes from by replacing the oxygen and nitrogen already present in the air, because they are in the maximum amount. Okay, and if oxygen and nitrogen are getting removed, and in place of that H2O water molecules are getting replaced, then obviously the effective mass will reduce. And since the effective mass is reducing, so what will happen? The density will also reduce, and if the density is reducing, then velocity will increase, because velocity is inversely related to rho. And now I am contradicting myself. No, I was contradicting myself when I was changing the density by bringing in the molecules closer to each other, but now what I am doing, I am replacing them. So the pressure remains same, the pressure remains P 1 atmosphere only when I am talking about the surface of earth, but now what I am doing is, I am just replacing those molecules of nitrogen and oxygen by molecules of H2O. and obviously they are lighter in mass as compared to the molecules of oxygen and nitrogen, because air has a fixed volume, similar amount of molecules will enter, right? So I'm just replacing them. So what happens, the effective mass reduces, and if effective mass is reducing, then density has to reduce, and if density is reducing, then velocity obviously will increase. And this is the reason the velocity of sound in moist air is greater than the velocity of dry air. So mothers scolding their child, the velocity travels at a faster pace whenever we are in the months from April, not April, from June, July, August, October till October, the humid air remains, and obviously the sound travels at a faster pace. Okay, and this will be the discussion about velocity of sound and effect of wind. Obviously, if wind is also blowing, then the velocity, the effective velocity also increases if it is moving in the same direction in which the sound is also propagating. But if the winds are blowing in the backward direction, so as you can see there, that's the reason I have placed a vector sign also over here. The addition will be vectorically. If winds are blowing in the same direction, then effective velocity or the speed of sound will increase. If in the backward direction, then the effective velocity and speed will obviously decrease. Okay, hello Pratap, how are you? You have a very good name. Okay, now this will be the discussion about velocity of sound waves. Now what we'll be doing, we'll be taking a very small break, and after coming from the break, we'll be talking about interference of waves and how interference of waves are done and why it is important, because without understanding this, we cannot understand how standing waves arises. Okay, so do have a quick look towards itself and try revising the previous concepts. If you face any difficulty in any of the questions, just rewind the video, summarize your mind, and just you yourself take a break. We'll be just arriving in 5 minutes. Okay, bye bye. Okay, so we are back again and obviously हम डिस्कशन करके गए थे वेलोसिटी ऑफ वेव्स के बारे में, ठीक है, कि कैसे चेंज होती हैं, क्या पैरामीटर्स होते हैं. अब बात करते हैं इंटरफेरेंस ऑफ वेव्स के बारे में कि इंटरफेरेंस ऑफ वेव्स क्या होते हैं एंड हाउ एम्पलीट्यूड चेंजेस. So let's say suppose there are two waves, okay, y equals to y1 equals to a1 sin omega t plus kx and यहाँ पे y2 equals to a2 sin of omega t plus kx plus y. So what principle of superposition says is wherever both these waves will meet, wherever they'll meet, the net resultant will be equal to y1 plus y2. So over here you can actually calculate them and उसके बाद फिर जो एक नेट एक्सप्रेशन आएगा आपका रिजल्टेंट वेव का, उसका जो एम्पलीट्यूड है, मेन हंट उस चीज़ के बारे में, मेन जो क्रक्स है पूरे प्रॉब्लम का कि रिजल्टेंट वेव का एम्पलीट्यूड कितना आएगा एंड द वेरिएशन ऑफ एम्पलीट्यूड विथ फाई, दैट इज द फेज डिफरेंस बिटवीन देम. इफ यू कैन सी द फेज ऑफ दिस इज ओमेगा टी प्लस के एक्स, द फेज ऑफ दिस फंक्शन इज omega t plus kx plus phi, so it is phi ahead of the previous function. So how amplitude changes of the resultant wave with the changes in phi, that is the phase between both of these waves. Okay, so the net resultant will obviously be equal to under root of a1 square plus a2 square plus 2a1 a2 cos phi, and you need to remember this expression by your heart. Okay, because whether you talk about wave optics or you talk about the interference over here, this equation is your key element, your key stroke, master stroke, which actually helps you in deciding what will be the amplitude of the net resultant wave which you are getting. Okay, and obviously this amplitude can be replaced by intensity as well, and amplitude square, the amplitude square is directly proportional to intensity. So over here in place of a net, a1, a2, you can very well replace their intensities, that I net will be equal to I1 plus I2 plus 2 times under root of I1 I2 into cos of phi, since intensity is directly proportional to a square. Okay, and now let's talk about a maxima and minima condition over here. So what happens is, I have very clearly told you that amplitude changes with the variations in phi, that is the phase difference between both these waves. So for a phase difference, the additions will be in such a manner that the net result is maximum, and for some values of phi, the additions will be in such a manner that the net result is minimum. Okay, and that's what we are going to talk about. So a constructive interference is the one wherein the intensity, the net intensity or the net amplitude turns out to be maximum. And how we can achieve the maximum result is, as you can see this a1 a2 square, you cannot change them, they are obviously meant to be the maximum values, right? These are the maximum amplitude of this wave and this wave. So the only change which you can do is, you can just try and adjust this cos phi such that this entire expression becomes positive, or this entire expression becomes maximum. So if cos phi turns out to be equivalent to 1, that's the maximum value of phi, cos phi, right? So if cos phi turns out to be equal to 1, then obviously this expression turns out to be its maximum value, and if cos phi turns out to be its least value, that is equal to -1, then this expression net amplitude will turn out to be the minimum value. Okay, and based on such thing, we can very well calculate the maxima, constructive interference and destructive interference conditions. So for I net to be maximum, cos phi should be equal to 1, and phi obviously should be equal to 2 and pi, where n can be any number, 0, 1, 2, 3, even integers. So all the integers can be replaced in place of n, and what you'll be getting, you'll be getting the values of phi for which cos phi turns out to be equivalent to 1. And if cos phi turns out to be equivalent to 1, so this expression is a1 square plus a2 square plus 2a1 a2, that is a1 plus a2 whole square. So the net amplitude turns out to be a1 plus a2, and just replace the value of I net in place of a net, it will turn out to be I net is equal to under root of I1 plus I2 ka whole square, or under root of I net is equal to under root of I1 plus I2. And if in case both the waves have the same amplitude, both the waves which are interfering have the same amplitudes, so obviously their intensities will be same. So in that case, replace this I1 and I2 by a common variable, that is I. So this will turn out to be 2 times under root I whole square, that is 4 times I, and this will be the value of maximum intensity, or you can also replace this A1 and A2 by A and A. So the maximum amplitude will turn out to be 2A. Okay, and I suppose you have just understood this result. This is the case of constructive interference. Okay, and if I talk about destructive interference, for that cos phi should be equal to -1, and cos phi, when it is -1, just check your skills, when it is -1, it is -1 at pi, right? And then it is minus 1 at 3 pi, it is minus 1 at minus pi as well. So the odd integers or the odd values of pi actually give you the value when cos phi is least, that is equal to minus 1. So then phi should be equal to 2n plus 1 pi. Very clear, where n can again be any number, because this expression will always give you a odd numeral in front of pi, okay? And del phi can also be replaced by k delta x. So just remember this expression, that k times delta x is equal to delta phi. So this is the value of change in phase with change in position, and do remember this expression because this is going to be used quite extensively when we will be studying wave optics. So when the path distance, this is known as the path change, the change in the path, and this is known as the change in phase. So with the change in path, how much amount of phase change or phase difference you are encountering, so this is what this expression is. So this phi can be replaced by k delta x, and k is obviously what? 2 pi upon lambda. So 2 pi upon lambda, delta x should be equal to how much? 2n plus 1 pi, and this pi gets cancelled, this lambda by 2 will go over here. So delta x should instead be equal to 2n plus 1 lambda by 2. So this is the case about delta x. Now what will be the value of maximum intensity and maximum amplitude then? So cos phi, turn it to be equal into minus 1, the entire expression turns out to be a1 square plus a2 square minus 2a1 a2, that is a1 minus a2 whole square. So the net amplitude will turn out to be a1 minus a2, and as a result the net intensity will also turn out to be I net equals to under root of I net equals to under root of I1 minus under root of I2. And if they are same, then the net intensity will obviously be equivalent to 0. That's the least possible value of the minimum intensity. Now with an understanding of this, let's now try and understand what a standing wave is. So what happens in a standing wave is that two waves having same amplitude and same time period frequency wavelength traveling in the same line, along the same line, but in opposite direction. So one wave over here, one wave over here, when they'll just superimpose, what instead you will find is, you will find a standing wave. That means the position, say suppose these are the 2 points and there's a string. So you'll encounter this kind of a wave wherein this particle will move, will have an amplitude this much, this particle will have an amplitude this much, and this particle will remain at its position, it will not move, it will appear that it is at rest for the entire duration till the disturbance is being created. So now all the, unlike the case in the travelling waves, every particle had the same amplitude, but over here this particle will have the maximum amplitude and the point where there is no amplitude. So based on that also, nodes and antinodal points are decided. Nodes are the points which have zero amplitude, and antinodal points are the one which have maximum amplitude. The best way to do that is just drop a drop in a cup filled with milk or in a cup filled with tea, and what you will see, you will just observe these increment in the waves pattern, and they just appear like that only. Okay, so that is actually a standing wave, because a wave generating over here gets reflected from the edges of the cup and it again comes over there. So both these waves superimpose and a standing wave is created. Okay, and what all things we need to actually understand between a standing and a progressive wave is, so in a progressive or a travelling wave, energy is transferred, and in case of a stationary wave, energy is obviously not transferred, because the medium particles, they just have a simple common oscillation, they have a same time period but a different amplitude, so it is not travelling. So energy, you cannot expect energy to be travelling, because obviously with the help of oscillations and the movement of medium particles, energy transfers from one point to another. So energy never transfers in a stationary wave. Also all particles have the same amplitude in case of a travelling or a progressive wave, but here there are some nodal points, some antinodal points, and rest other points will have their amplitude between this maximum antinodal point and a minimum nodal point. At nodes obviously amplitude is 0, and at antinodes amplitude is maximum. Okay, over one wavelength span all particles have different phase, and over here all particles have same phase. So what do I mean by that is, let's say suppose you have a wave like this, a standing wave. So the time at which this particle will reach its maximum value will be the time at which this particle will reach its maximum value, and will be the time at which this particle will reach its maximum value. So all are in the same phase. Everybody is performing the same SHM with different amplitudes in the same time interval. Okay, no point is at rest. Here there are some nodal points which are at rest, they aren't moving at all, and all particles do not cross the mean position simultaneously. Over here all the particles cross the mean position. Which is the mean position? This line. So the motion of this particle is just like this. Over here it's like this, over here it's like this. Okay, so this is the expression, this is the pointers which you need to mind whenever you need to differentiate, have a difference in your mind as well about stationary and progressive waves. Now let us look at some standard cases of stationary waves. So over here we'll have to look for organ pipes and stationary waves getting created on strings as well, closed at both ends, and the best case study for this is a sonometer. So I'll be telling you how a sonometer even works. Okay, so a standing wave on a string, how can that be created? So suppose we have a string which is closed at both the ends. So obviously since it is closed at both the ends, we have a restriction that the points, the string points which are at the end points where the string is attached with the wall, they cannot move. They cannot have an amplitude equal to A or 2A or 3 or whatever the value is. They obviously have to remain over there, and as a result two node points or two nodal points are very well clear before even a wave has even been created. So these end points will always be nodal points, and whatever disturbance is being created will be adjusted between them. So this kind of an adjustment can be created? Yes. Can this kind of an adjustment be created? Yes, obviously. Since these two parameters are satisfied, you can create as many of them, and based on that harmonics have been determined. So this will be the first harmonic possible, this will be the second harmonic possible, this will be the third harmonic possible. Apart from the first harmonic, this is also known as the fundamental node, okay, or the fundamental tone, okay, and this is also known as after the fundamental first overtone, obviously, and this will be known as the second overtone. Why second tone? Why element of tone is arising? Because since the wavelength of the wave, the velocity will remain same because the tension is same, the mass per unit length is same, so velocity will remain same. Velocity की value change नहीं हो रही है. What is changing is frequency is changing, and along with that lambda will change. V has to be equivalent to f lambda, right? V will be equal to f lambda. So you can see in all the cases lambda is different. Suppose if I talk about there, this entire length L is equal to lambda by 2, true? Because half a wavelength is being created, right? This is half of the wavelength. And over here if I talk about, then the entire wavelength is equal to lambda. And if I talk about here, then there is 3 by 2 times lambda, that is equal to L. So there are different wavelengths getting created, and as you can see, the wavelength over here will be equal to 2L, the wavelength over here will be equal to L, and over here it will be equal to 2L by 3. So it is getting reduced, and since it is getting reduced, the frequency will get increased. So depending upon different harmonics, frequency gets increased. So first harmonic will have the least frequency, and the nth harmonic will have the maximum frequency. Okay, and the expression for the nth one I can very well write in front of you. So as you can see over here, the length is 2L by 3, right? Over here it will be 2L by, see, suppose the lambda can be represented as 2L by n. So if I place n equal to 1, over here you can see lambda 1 equals to 2L, right? If I place n equals to 2, then that becomes 2L by 2, that is L. So lambda equals 12. If I place n equals to 3, then that becomes 2L by 3. So over here it is. So lambda can be calculated using this. This is the expression for the nth lambda, and based on that I can also create the frequency of nth one. So frequency, how it is related? V is equal to f lambda. So that means f is equal to v by lambda. So just replace v by 2L upon n, that amounts to nv upon 2L, and this is the expression for nth frequency created on a wire which is hinged or which is fixed between two closed ends, two fixed ends. So this will be the frequency of nth harmonic possible, or the n minus 1th overtone. Okay, I suppose you have understood it. Now let's the most what I should say, the most brilliant case study of this is a sonometer. So what happens in a sonometer is tension is being created with the help of this mass, and this is a wire basically running between two bridges. So these two bridges obviously act as those two fixed points, and the wires over here cannot have a maximum amplitude, and over here as well. So that situation has been created, and between them what happens is a frequency is created using a tuning fork. A tuning fork is just pressed against something and it is just brought near to it, and based on the tuning fork, frequency or the disturbance, the standing wave is created on this stretch. So if one rider type of a thing or a one very lightweight paper clip is placed just in the middle of that, and if that paper clip just jumps off this wire, then what is suggested that a fundamental node or the first harmonic wave has been created. A standing wave has been created where this particle will have maximum amplitude, and this is the reason why that paper clip got jumped off from this wire where it was placed. Okay, so this is the experiment which is done, and I'm sure all of you must have missed it due to COVID. Most of you haven't seen the schools from past so many times, but this is an experiment which is performed in schools. Okay, so it's a very interesting experiment. Just place the paper clip over here and just change the tuning forks, and depending on the changing of tuning forks, you can even at the first case it will be in the middle, and if you increase the value of frequency, so obviously on increasing the value of frequency, some second or third or fourth harmonic can also occur, and based on that, on keeping the paper clip at some distance, not at the middle but closer to the right bridge as well, you will encounter that the paper clip has just jumped off. So it's a very very cool kind of an experiment, and if you ever get a chance, just practice it up. Okay, now let's solve this question. So what happens is a sonometer wire of length 1.5 meter is made of steel. The tension in it produces an elastic strain of 1%. Okay, what is the fundamental frequency of steel if density and elasticity of steel are given to as this and this respectively? Okay, so what is the fundamental frequency of steel if density and elasticity of steel are there, and the wire, the sonometer wire, is made of steel obviously. Okay, this wire which I was telling you about, this is made of steel. So we need to find the value of fundamental frequency. Now what is the value of fundamental frequency? Obviously it will be when this kind of a standing wave is created, that is lambda by 2 will be equal to L, true, and lambda will be equal to 2L. And what will be the value of frequency? So frequency will be equal to, it's V by lambda, right? V by lambda, so V by 2L. So are we given the value of length? Okay, length is given to us. Do we know the value of velocity? No, we don't. So we need to find the value of velocity. So how can we find the value of velocity? Sir, I remember a formula. So this is a wave, right? And it is getting created. So this might have been created by the traveling of waves and the superposition of two traveling waves in opposite direction, right? So the velocity of the wave's direction will obviously be equal to under root of t by mu, since waves, transverse waves are generating. So velocity's relation is under root of t by mu. Do I know the value of tension? No sir. We just know that tension in it is producing an elastic strain of 1%. Okay, we don't know the value of t. We even don't know the value of mu. Okay, not an issue. But we know a chapter, we have studied a chapter, and even we have a crash course about it, mechanical properties of solids. And if you haven't noticed it or had a watch for it, then go watch it after this session. So there what you will realize is that strain has been given to us, right? Elastic strain has been given to us as 1%. That means delta L by L has been given to us as 1 by 100. So this strain can be replaced by stress upon Young's modulus of elasticity, right? And the stress will be obviously equal to the tension divided by area into Y, that is Young's modulus of elasticity, and that is turning out to be 1%, that is 1 by 100. Okay, so very well. Now this value we know, this value sir we know. Okay, so now what we need to do is we need to try and adjust some figures over here, because what we have provided up with is the density of the wire and the elasticity of steel, that is the Young's modulus of elasticity. So can we create a figure over here? Let's just try for it. So V will obviously be equal to under root of t by mu. What I am going to do is I am going to multiply A and A over here. Okay, and on multiplying A and A over here, one thing I just received, and also I'll be multiplying Y and Y over here. Okay, so the benefit of this is that t upon A into Y, the figure I very well know it is equal to 1 by 100. Okay, that you have discovered. Very good sir. Now what more I can do is this mu, what it is? What is mu? Mu is mass by length. That is mass by length. So if that A comes over here, just look forward to it. So this is T upon A into Y, this I very well know, and this mu can be written as 1 upon mass by length. And A was written in the numerator, वो ऊपर था numerator में, so it can come over here in the denominator of this expression. So I can write it over here, right? And Y is as it is. True, sir, very true. And what is mass upon length into area? Length upon into area is volume. So mass upon volume is what? It is density. It is density. So this can be replaced by density, and T upon A into Y you very well know. So you just need to replace the values now, and if you want the expression again, I'll just mention it up. So this is obviously equal to strain into Y divided by density. So the velocities expression now got converted into this. So do you need to remember this formula? I would not suggest you to remember this formula. You know this one. You just need to do some maneuvering and you can obviously get down to this result as well. It's not a big deal. I just did it in front of you. Even I wasn't remembering this formula. This is not of such great importance as well. So we know the value of strain, we know the value of Y, and obviously we know the value of rho as well. We can very well replace it over here. So what this value will turn out to be, strain is 1 by 100. What is the value of rho? Rho is 7.7 into 10 raised to the power 3. So 7.7 into 10 raised to the power 3, and in the numerator it will be 2.2 into 10 raised to the power 11. Okay, very nice, sir. This this decimal will get removed. It will be 2 and 7, 11 2s are 11 7s are. Then the next thing will be 10 will go over there. So 10 raised to the power 5 will get cancel this 6 powers over here. So 10 raised to the power 6 will arrive over here, and that can very well be removed outside. But what I'll do is I'll just remove 10 raised to the power 4 outside. So this will turn out to be 100 into, inside it will be 100 by 7. So what is 100 by 7? 100 by 7. It will nearly be equal to 1, 7, 30, 14 point something. It will nearly be equal to 14 point something. And what is the under root of 14 point something? So what is the value? It will be 1, 4, 14.3, and 14.3 is near about, so 3 square is 9 and 4 square is 16. So it will be nearly equal to 3.8 something, around that. And let's just keep this figure for the time being. So it will be 100 into under root of 100 by 7, and we know the value of frequency over here. We just have to divide it by 2L and we'll get the final value. So V is turning out to be 100 into under root of 100 by 7. I am just writing it down just to see whether some calculations or some deductions can occur, and that can just ease up my calculative approach over here. So what is the length's value? It is equivalent to 2 into 1.5, that is 3. Okay. So 100 by 3 into 100 upon 7 and 14.6. So 14.6, it's nearly equal to, see, 3 square is 9 and 4 square is around 16. So the value will arise between 3.6, 3.5, okay, and 3.6, 3.5, no, it will around be 3.8, okay. I'll calculate the value, not a big deal. I'll just calculate it over here. So 100 upon 7 will be 14.1, 4.3. 14.3, I just need to find the under root, so it will be 339, it will be 5, 30 and 336, so 6 around 68, right? 8 6 are 48. So it will be around 68 or 67, and here it will be 3.7, and 3.7 will be the result over here. Just dividing it by 3 will turn out to be 1.2 something. Am I doing it right? So this is your actually, see, you can just calculate the value of this under root on your own. Okay, you just need to calculate the value of this under root and just multiply it with 100 by 3, and you will be getting a value close enough to 178.2 hertz. Okay, so I'm just having that space crunch also over here. So you just calculate this value, you'll get a value near to this result only, and basically what we need to understand is the physics behind it, and we have dealt with that very easily. All is remaining is that final calculations which we need to do, and that can be done very easily. Okay, let's move ahead and talk about the organ pipes as well, wherein so we had a discussion about the standing waves created between on wires between two fixed points, right? But similar kind of a thing can occur with longitudinal waves as well, and open organ pipes are somewhat like that, which actually depict you how longitudinal waves can also create a standing wave. So suppose you are making a noise. This is an organ pipe which is closed at one end. You're making a disturbance from this end, a longitudinal. You're making a sound. So that sound will obviously travel. It will get reflected from this point, and it will again come back. And on coming back, a standing wave will again be created. So that organ pipe, this is a closed organ pipe. There is an open organ pipe as well. So in a closed organ pipe, what happens is this point which you are viewing over here will have the least displacement. So the medium particles obviously have a closed end at this point, so they cannot move in the downward direction. So here the displacement of particles will be least, and obviously a nodal point of displacement will arise over here. But if I talk about the pressure, so pressure over here will be maximum. So this point which you are seeing over here, over here, over here and over here, these points, the point N, they have been determined or represented as the displacement nodal points. Okay, because here the medium particles cannot displace, but at the same time, if I talk about pressure, then pressure over here is maximum. So pressure antinodal points are over here. So the same graph which you are seeing for a pressure variation, the graph will turn out to be like this. Okay, so this point will have a pressure antinode point. If I talk about this curve, then the pressure antinode will be like this. Okay, so pressure antinode will arise over here, pressure antinode will arise over here, and similarly this kind of function. So what nodal points have been mentioned in front of you are about displacement. Okay, so displacement nodal points are obviously over there, and we need to draw the entire harmonics based on this condition only, that at this point where the end of that pipe is occurring, nodes are occurring. Okay, nodes will arise, and the first harmonic obviously in this case will be when over here the maximum amplitude is occurring, the maximum displacement, and over here node is occurring. The other case will be over here maximum displacement is occurring, and over here nodal point is occurring with a node in between as well. So as you can see, this is the length of lambda by 4, and lambda by 4 will be equivalent to L over here. Over here it will be 3 times lambda by 4, not the double of it. And this is the reason this is known as the first harmonic, this is known as the third harmonic, because it is thrice of that function, unlike the cases. And just now we will be discussing about closed organ or open organ pipes as well. So this is a closed organ pipe, and in these cases only odd harmonics occur. So this is the fundamental node or first harmonic. This is the first harmonic, okay, and this is obviously the third harmonic, this is the fifth harmonic, because it is 5 times lambda by 4 equivalent to L. Okay, and obviously after, if you are knowing the value of lambda in terms of L, you can very well calculate the value of frequency as well. So this will be the frequency for nth lambda, third lambda, and using this result only I can calculate the value of nth lambda as well. So n3 will be equal to whatever the value of n is there. So n obviously should not be equal, it should not be an even quantity, it should obviously be an odd value, and that is expressed using 2n plus 1. Okay, so this will be the expression for the third harmonic, the second harmonic, and the first harmonic. Do keep this in mind that even harmonics are not possible whenever we have a discussion about closed organ pipes. Okay, and if I talk about an open organ pipe, so what will be the condition in an open organ pipe? It is opened at both the ends. So over here the displacement can be maximum, over here displacement can be maximum, over here displacement has to be maximum, and this is the condition which we need to satisfy. And on satisfying this condition, we can very well draw this to be the first harmonic possible, and the second harmonic is obviously the double of it, right? Over here the length will be twice of this function, 2 times lambda 1 by 2, so it will be lambda only, and over here it will be just thrice of this. So over here first, second and third harmonics are possible. Okay, and this is the first harmonic, this is the second harmonic, this is the third harmonic. This first harmonic is also known as fundamental mode. This will be the first overtone, this will be the second overtone, and based on that you can carry on with your functions. And I suppose you have just got the crux of it, how standing waves are getting created in open and closed organ pipes, and do practice question on that. Okay, in the app, when you'll just download it, I want you all to practice as many questions as you can on organ pipes. They are very important, and so many times questions have been asked from them. And there's one very strange thing also with organ pipes, that but first let's do this question. Okay, so what this question says is a pipe open at both ends has fundamental frequency F in air. So it is obviously an open organ pipe. The pipe is dipped vertically in water so that half of it is in water. Now this open organ pipe has been converted into a closed organ pipe. The fundamental frequency of the air column is now. Okay, so the fundamental frequency when it was in air, so this was the case, and this will obviously be the first harmonic, the fundamental harmonic. As you can see over here, this entire value will be equal to lambda by 2, right? This is the half of the function of wave. So this half is over here and this half is over here. So this is lambda by 2 is equal to L. True? Very true. Now if lambda by 2 is equal to L, then I can very well calculate the value of frequency over here as well. Lambda will be equal to 2L. And now the frequency will be F times lambda, V by lambda. So V upon 2L, this is the fundamental frequency in this case, right? Very right. Now what we are doing is, we are submerging this organ pipe in water such that half of its length now is in water. Okay, and this is the case. So beneath this it's only water. So now this open organ pipe has been very well constructed or transformed into a closed organ pipe, with one of its end as open and on the other end as closed. So now what will occur over here is the fundamental frequency will be this only, wherein there is a displacement node at this point and displacement antinode over here. Or if I talk about pressure, then pressure antinode will arise over here and pressure node will arise over here. They are not similar, where pressure node is there, displacement antinode is there. So keep that differentiation in your mind. So what will happen over here is this length will obviously be lambda by 4, and over here lambda by 4 will be equal to not L, because half of the length is submerged, so it will be equal to L by 2. So what will be the value of lambda? Lambda will be equal to 2 times L. So now how will the frequency change? So F dash will be equal to V divided by lambda, that is 2L. Just a minute. So lambda by 4 will be equal to L by 2. A pipe opens at both ends, has fundamental frequency F in air. The pipe is dipped vertically in water so that half of it is in water. The fundamental frequency of air column is now. Okay, so this will be the value of fundamental frequency, and this is obviously lambda by 4. So lambda by 4 will be equal to L by 2. So lambda will be equal to 2L, and over here lambda by 2 was equal to 2L. So F dash will be equivalent to V by 2L, and this is the wrong expression. The right answer is this one only. Let me check again. The pipe open at both ends has fundamental frequency F in air. Okay, so this is the fundamental frequency. Lambda by 2 will be equal to L, and L will be equal to F is over here, and it will be 2L. This is the case. So the right answer is F only. Okay, true. Now let's talk about so a resonance tube. So a resonance tube is actually as in the case of a sonometer, which was actually depending upon, that was the case study of the standing waves created on wires, right? So sonometer was the case study of that, or the example or the application of that, and based on the applications of open organ and closed organ pipes, we have sonometer into, or not sonometer, we have resonance tube as the applications of standing waves in organ pipes. Okay, so what happens in a resonance tube is that water is filled over here, and we can very well note down this length in which that standing wave will be created with the help of the scale given over here, and a tuning fork is just brought over here at the topmost point, and based on this tuning fork, जो भी frequency tuning fork में create होगी, यहाँ पे standing wave create हो जाती है. तो obviously the case is of a closed organ pipe. So first harmonic is possible, then third harmonic is possible, then fifth harmonic is possible, and based on that we do the calculations. But one more very strange thing happens over here. Some kind of end correction also comes into action. And what is end correction is that the point where you are viewing the displacement antinode is not occurring at the exact edges of the tube. It is occurring at a bit higher than that. मतलब जो exact point है ना आपका, जहाँ पे डिस्प्लेसमेंट के एंटी नोड्स आएंगे, वो इस लेवल से थोड़ा ऊंचा आता है. ठीक है, वो इस लेवल से थोड़ा सा हाइट पे आता है, एंड ये जो हाइट डिफरेंस है इसको हम एंड करेक्शन बोलते हैं, ठीक है। और एंड करेक्शन को कैसे कैलकुलेट किया जाता है? सो व्हाट यू जस्ट नीड टू डू इज द इफेक्टिव पाइप लेंथ जो होती है, सपोज यू हैव द एग्जैक्ट पाइप लेंथ टू बी एल, बट जो आपका स्टैंडिंग वेव क्रिएट हो रहा है वो एक पॉइंट ऊपर जा रहा है, मतलब जो एंड पॉइंट है उससे भी ऊपर जा रहा है। एंड इसी चीज को तो हम इफेक्टिव लेंथ जो होगी पाइप की उसको यहाँ पे काउंट करेंगे अपनी कैलकुलेशन से, एंड दैट विल बी इक्वल टू एल प्लस ई, ठीक है। सो एल डैश नाउ विल बी इक्वल टू लैम्डा बाय 2 ओवर हियर, नॉट एल। और इफ आई टॉक अबाउट ओपन ऑर्गन पाइप, सो एंड करेक्शन नीचे भी होगा ऊपर भी होगा। सो यहाँ पे एल डैश जो कि हो जाएगा एल प्लस 2 ई, एंड दिस विल बी ऑब्वियसली इक्वल टू lambda by 2. So L plus 2E now will be equal to lambda by 2. This is the only correction which you need to do, and this is viewed, ये होता ही है. So we need to calculate and keep this end correction in mind whenever we are studying about end correction or whenever we have questions based on resonance tube as well. Now let's talk about another very important thing as beats. So if you all must have been hearing DJs and YouTube music nowadays, so people play with beats. So how beats are created? First of all, let's understand that. So beats are actually created by intermixing of two frequencies. Okay, so we have a sound of one frequency, we have a sound of different frequencies, and if their frequency range is such that you can view it, you can understand it. So obviously if there is 230 hertz, then you cannot differentiate the maximum and minima clearly, and you will hear a clear cut sound, right? But if the frequencies are near to 4 or 3 or 5, that is a up down up down up down in a second. So 4 hertz, that means 4 cycles in a second, so your ears can very well differentiate them up. Okay, and there this comes the case of beats. So that time beats can be clearly observed. But how beats are actually occurring is by the superimposition of two waves of different frequencies, and if their frequencies lies in the range of 4, 5, 6, then you through your ears can obviously the beats will be audible to you, or else the beats won't be audible to you. Okay, and this is the case of beats. And the beat frequency, how it is just calculated is the subtraction of one beat frequency one sound wave frequency minus another sound wave frequency. So suppose if you have a sound wave frequency of n1 or nu1 or f1, then just subtract it with another sound wave frequency, and what you will be receiving is the beats. You will be observing the beats. There will be portions when the sound, the superimposition of sound has a maximum value. There will be a point where the superimposition of sound has a minimum value. So that maximum, minima, the amount of times it occurs, the amount of oscillations it occurs because of the superposition. Basically, it's just that the resultant wave now will have a amplitude higher, then it will have a lower amplitude. Cycles will be created, and those cycles is what beat frequency is. Okay, so it's a normal formula that how beat frequency can be calculated. Even time period, beat period can also be calculated. You just have to divide it by 1 and you will get the value of beat period as well. Okay, okay. Now let's talk about the famous Doppler's effect. What is Doppler effect? So it is actually the change in frequency which we observe when a source and the observer are actually moving or having a relative motion between them. So suppose there's this car and it is actually horning and horn chal raha hai uska. So what happens is, if this car is moving in forward direction, the frequency which this person will observe will be different from the frequency which this person will observe, because sound is propagating in forward direction and to him the source is moving towards him, but over here what is happening is the source is moving away from him. And there's a very normal and a simple formula to actually evaluate these things, to actually calculate these things and quantify them, and the formula is what Doppler's effect is all about. So what happens in a Doppler effect, it says that the net or the apparent frequency as heard by an observer with relation to the frequency as emitted by the observer or by the source. So suppose the source, whatever the source you have which is creating sound, एक source है जो कि sound create कर रहा है, जो frequency create हो रही है, that is of the value n or nu or f, whatever the frequency value is, and जो observer है उसको एक अलग frequency सुनाई दे रही है. So what will be the frequency observed by the observer? Let's say it is nu dash or f dash. So that can be related by this result, that v plus vm, where vm is obviously the velocity of the medium. So this is the case when observer is here, source is here. So this is the source, this is the observer. It is having a velocity VO, it is having a velocity VS, and also sound is traveling in forward direction. So this result holds good, and also medium is also moving in forward direction. So this result holds good when all are in the same direction. If any of them is not following the convention, add a negative sign in front of them. Okay, you got the result. This is the case when source is over there, it is moving forward, observer is over there, it is moving forward, then medium is also moving in forward direction, and sound is also propagating in the same direction. It is not having a horn over here such that sound is moving in backward direction. Sound is also propagating in forward direction. Then the apparent frequency will be equal to V plus Vm minus Vo upon V plus Vm minus Vs, where V is the velocity of sound, Vm is the velocity of the medium, and Vo and Vs are the velocity of observer and the source. Okay, so this is the result, and this is the main expression through which we can calculate the apparent frequency as heard by the observer. Okay, and if suppose the medium becomes stationary, if the medium becomes stationary, then what will happen? Then in that case, that Vm element will turn out to be 0, so it will entirely be V minus V upon V minus Vs. Okay, and this is more commonly used. Medium's velocity is not taken into account, but you should have a clear sight if medium's velocity comes into picture, then how the variations will arise. Okay, and this will be the final expression of Doppler's effect. Now there are some conditions also when no Doppler effect is observed. And what are those conditions? So the first one is when source S and listener L both are at rest. So let's say both of them are at rest and there is no relative motion between them, then obviously what we can say is that no Doppler effect will come into action. When medium alone is moving, just the medium is moving, no sound is getting created, and nothing such sound is not created, then the first case is also not possible. There will be no discussion of Doppler effect if only air is flowing. Okay, so that is also the case when S and L move in such a way that the distance between S and L remains constant. So obviously when both of them are just moving in forward direction, the distance between them, there is no relative motion between them. So the entire case of Doppler effect is when there is relative motion between them. If relative motion is not between them, then obviously Doppler effect will not come into picture. Okay. When source S and listener L are moving in mutually perpendicular directions, so when they both are moving in such a fashion, let's say I talk about a circular motion. So let's say there is a source and there is an observer. So observer is moving in a circular direction. So as you can see, always the velocity of the observer will be mutually perpendicular to the distance between them. So in this case also the frequency as heard by the source will be same throughout. It won't change. Okay, and this is the case. Okay, if the velocity of source and listener is equal or greater than the sound velocity. Now suppose if their individual velocities are in 3000, 5000 or 100,000, they are in the supersonic range. So obviously then also Doppler effect won't be occurring, right? Because their individual velocities are too much. So what will be the effect of this velocity on them? Nothing, nil. So in that case also Doppler effect will not come into picture. Okay, and now let's solve this question to understand what we have just learned and what all standing waves concepts we know about. Hi Vishnu, how are you? I'm very good here, Vishnu. What about you? So a travelling wave represented by y is equal to a sine omega t minus kx is superimposed by another wave represented by y is equal to a sine omega t plus kx, and as you can see their directions are obviously opposite to each other. If you're viewing it, the velocity of this will be minus of coefficient of t upon coefficient of x, that is minus omega upon minus k, that is omega by k, positive x, and over here it will be negative x. So they both are moving in opposite directions. So as usual a standing wave has to be produced. So standing wave will be produced, a wave travelling, this option will be eliminated at the first case itself. Now how that travelling wave will be created or how that standing wave will be created, let's understand that. So according to principle of superposition, the resultant will be equal to y1 plus y2, that is a sine omega t minus kx plus a sine omega t plus kx, right? And if I just do it like sin c plus sin d over here, so what the result will be, a times sin c plus sin d, what it is, 2 sin c plus d on 2 into cos of c minus d on 2. So sin of c plus d on 2 will be this plus this by 2. So minus kx will get cancelled, so it will be sine of 2 omega t by 2, and cos of c minus d on 2, that will be 2 times kx by 2. Negative sign will be absorbed by the cos function, and the expression will be like this. 2 gets cancelled, and I just want to place this with this element. So it will be 2a cos of kx into sine of omega t. So this is what the at these values of x, if suppose cos kx turns out to be 0, then at those points the amplitude, this is the amplitude of a standing wave, right? So at the points where cos kx turns out to be 0, the standing wave will have nodal points. So what will be the points where this entire expression turns out to be 0? This will be the case when cos kx turns out to be equivalent to 0. That means kx turns out to be equivalent to pi by 2 or 3 pi by 2, right? So those are the values. So can we mention them? Yes, we can. So what are the values when cos kx is equal to 0? They are obviously when kx is equal to, so at pi by 2 it is, at 3 pi by 2 it is, at 5 pi by 2 it is. So I will express it as 2n plus 1 pi by 2, and that's true, that's very true. I can also replace this k by 2 pi upon lambda. So it will turn out to be 2 pi upon lambda into x is equal to, I can move this 2 over here, so n plus 1 by 2 times pi will give me the value of x, and this pi will get cancelled by this pi, this lambda can be moved over here, so x will turn out to be n plus 1 by 2 times lambda by 2. So if I replace n by 0, then it will be lambda by 4. If I replace n by 1, 2, 3, 4, then accordingly you will find the values of x. So which of them options is correct? N plus 1 by 2 lambda by 2, this one. A option is correct? Yes, A option is correct, right? So this is the expression for this answer, and I suppose you understood it and you liked this entire video. So this will be the end of this session. We'll be meeting in the next discussion, next topic, and the next topic will obviously be the first topic of class 12th, that is electrostatics first portion, and we'll be discussing about that on 11th of Feb 5 p.m. Till that time, what you need to do, you need to download the app and practice as many questions as you can based on the topics and the concepts which we learned today, so that waves becomes a very good chapter of yours and you might not face difficulty in solving questions based on it when they arrive in the final exam. We'll be meeting, note down the date and note down the time as well, okay? So the topic will obviously be the first part of electrostatics 1. Till then, happy learning, bye bye.